Hello, welcome to the lecture of engineering mechanics. In the last video of equilibrium, we have discussed what is equilibrium, what are the conditions, what are the equilibrium condition for different situation like particle, system of particle. Then we saw the condition for two force member, three force member, free body diagram, total system free body diagram, and also we see the types of supports, and then we discuss truss, type of truss, and the method to solve by the method of joint, and to solve the truss by method of section, and the some special case like zero force member. So there is two case in the special case. Okay, and then we saw by the total system free body diagram the support reaction can be calculated, and I have done one numerical in the last video. In this video basically I will cover a lot of numerical based on the concept I have discussed with you in the last video. So there is a slide which was not visible in the last video. I'll show that. See, this is the slide. This portion of the slide was not visible. Okay. So I was talking in this slide. It's three types of support. It's a roller support, hinge support, and a fixed support. Roller will give one reaction, that is only vertical reaction. Hinge will give horizontal as well as vertical, so it will give two reaction. These are two unknowns. Okay, this is the fixed beam. Okay, the cantilever, one is fixed, other end is free, that's called cantilever beam. Okay? So in these three type of reaction we will get, that means we will get an horizontal reaction, vertical reaction, as well as moment reaction. What are the reaction means resistance. Whenever we apply certain amount of load, whether it's a static like concentric load or a rotating load, that is a moment, that load, applied load, will be balanced, or that load will be resisted by this resistance reaction created by the support. Okay, so this is the slide which this portion was not visible. Okay, after that we discuss about truss. Okay, then we discussed what are the assumptions like weight of the member neglected, all the loads of the members, and all the loads and member are lies on the same plane. Then joints are frictionless. In the next slide, we talked about different type of condition for stable and indeterminate and the deficient truss. Okay, all these things we have discussed in the last video. So in this video basically we are going to discuss about some of the numerical. So what are the concept we have discussed in the last section? I will just write it down, the most important thing we learned from the last video. Okay, so the first thing was equilibrium condition, that is net force is equal to 0 and net moment is equal to 0. In that case the body will be in equilibrium. So this is the generalized condition. Net force is equal to 0, net moment vector is equal to 0. For 3D, the force will give 3 component, the moment vector will give 3 components. So total 6 equilibrium equation we have in 3D. 6 equilibrium equation. Okay. In 2D, we have only 3 equilibrium equation. 3 equation. Okay. What are these? Because in 2D, we have discussed net force in x is equal to 0, so no translation in x. Then net force in y is equal to 0. Then net moment about z is equal to 0. This is the equilibrium equation we are going to discuss and apply in the numerical. Okay, so this is the about equilibrium in the last video. Then we got a concept of two force member. If there is a object which is under action of two force and that object is in equilibrium, in that case I have said that these two forces must be equal in magnitude, opposite in direction, and collinear to each other. That was the condition. Okay, then the third one was if there is three force and the object is equilibrium under these three force, then they must be concurrent. Okay, they meet at a single point P, Q, R. So Lami's theorem we are applying. Suppose this angle is theta 1, this is theta 2, this is theta 3. So Lami's theorem, the most important theorem for 1 mark question, it will be P by sin theta 1 is equal to Q by sin theta 2 is equal to R by sin theta 3. What it is saying? P is the force. See, this is the force P. Okay. P divided by the sine of angle between other two. Q divided by sine of angle between other two. R divided by sine of angle between other two. That is Lamy's theorem. Okay. This is the three concept for equilibrium. Okay. Then we saw about the free body diagram and total system free body diagram. So in the FBD, four thing was included. Number one, weight. Number two, external load. Number three, support reaction, whether it's normal reaction or we can say the friction. In the fourth, if the body is in dynamic, that is the inertia force. Free body diagram means isolating. Okay. Isolating the desired part, we want to draw the free body diagram. Total system free body diagram. In this, we just need all the four, 1, 2, 3, 4, all the condition. The next only thing is that we should remember no internal reaction should be shown. This is all about the equilibrium condition. Okay. And there was a note I have written in the free body diagram that tension at any point is always shown towards other end. So after the last video, if you just remember these two slides, whatever I written here, these are sufficient to do or answer any type of question related to equilibrium. And we have discussed roller will give only vertical, hinge will give horizontal and vertical, and the fixed support will give horizontal, vertical as well as moment. Okay, so it will give only one, here it will give two, this one will give three reaction. Okay, these are the support reaction given by the roller support, by the hinge support and fixed support. So we'll next go to the questions. Okay, so now read this question carefully. What it is given, it's a statement time, 1 mark question. Okay, the condition for equilibrium, he's saying the condition of equilibrium are satisfied only when, that means it is saying that it is mandatory condition when the force are collinear and coplanars. In the assertion is saying for equilibrium condition is for the whenever the force are collinear and coplanar. Is this the condition for equilibrium? Not at all. In the 3D we have seen we have total 6 equation. So this is not a equilibrium. The object 3D object was in equilibrium, but there is nothing mentioned that it should be coplanar and collinear, nothing like that. So assertion is wrong. Then the second statement is saying assertion wrong. Reason is saying the independent equilibrium equation. He is talking about independent equilibrium equation available for any given problem depends upon the nature of the force system. See, we have seen the nature of force system, parallel force system or a concurrent force system. Okay, like this they are meeting at a point, or we can say a coplanar force system for 2D or any combination of force. See, in this type of force system we have only equation like net force in horizontal direction is equal to 0, or we can apply net moment is equal to 0. We cannot apply the net vertical force is equal to 0 because there is no vertical force. So this equation is not applicable for this force system. So only two. In a concurrent force system we can apply net force in horizontal direction is equal to 0, net force in vertical direction is equal to 0, but we cannot apply the net moment about that point. O is equal to 0. This equation cannot be applied. Okay, so only we have two equations. So depending upon the force system, we have different equilibrium equation available. So this statement is correct. So assertion is false, but R is true. This is the answer. Okay, we'll go to the next question. Here see the question carefully. What it is asked in this question, the minimum number of constant means restriction. See kochi minimum number of restriction, or we can say the member that तमे restriction केतेडा कि member that needs to be removed सेडा को हमें काढ़िया दरकार कौन पे ना from the truss assembly to convert it into a mechanism. See truss मु कहितली truss is used for load carrying. Okay, load carrying. Mechanism means there will be relative motion between the component. Relative motion will be there. So it is not a static. So in that case, it is an example of deficient truss. Deficient truss. In that condition, what was the condition? The unknown was less than the equilibrium equation. So unknown means the number of member and the reaction. Here see it is a hinge, so it will give a vertical reaction. Again it will give a horizontal reaction. It's a roller, only give a vertical reaction. So the reaction plus member 2J. This was the condition for the deficient truss. Okay, so R is 3. Member, count the member. It number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11. Less than 2 into J. Joint 1, 2, 3, 4, 5, 6, 7 into 7. So this one is 14. This one is, see, this is the member is 13. 11 plus here we left 2 member. 12, 13. So 13. Here is 16. Our aim is to make this unknown less than this 14. 14 is available. So we need to subtract 3 from the 16. So we need to remove 3 member from this truss so that it will be a machine. So this will be the answer. Okay, option C. So here is a question. See, how many equation in addition to those available from the principle of statics. आमे जेते जाको इक्वेशन पढ़ीचे प्रिंसिपल ऑफ स्टैटिक्स रे ता बदल रे आ केतरा एक्स्ट्रा इक्वेशन दरकार कोन भाई टू सॉल्व ऑल अननोन फोर्स एंड रिएक्शन. अननोन फोर्स भी अननोन हला, रिएक्शन हला इन ए प्लानर कैंटिलीवर. से को जे सिस्टम रे केतरा हमें अननोन आगे कैलकुलेट करिया. अननोन माने m प्लस r ए केतरा अछि मेंबर काउंट करा. गोटे दुईटा तीनटा चारटा पांचटा छटा सातटा आठटा नौटा 10टा 11टा. रिएक्शन केतटा अछि एटा गोटे हिंज, एटा भी हिंज. ये दबो गोटे हॉरिजॉन्टल, ये दबो गोटे वर्टिकल, ये दबो गोटे हॉरिजॉन्टल, ये दबो गोटे वर्टिकल. सो चारटा रिएक्शन 11 4 15टा. ओके, जॉइंट केतटा अछि देखो गोटे दुईटा तीनटा चारटा पांचटा छटा सातटा. सो इक्विलिब्रियम इक्वेशन केतटा अछि 2J. गोटे दुईटा तीनटा चारटा पांच छटा सातटा 14टा अछि. ठीक अछि. मेंबर अछि 15टा ना 16टा. देखो एडी हम आउट छाड़ दे 1 2 3 4 5 6 7 8 9 10 11 12. यस एडा हम 12 प्लस 4 16 मेंबर. टोटल अननोन 16टा अछंती. हम पाखे इक्विलिब्रियम इक्वेशन अछि 14टा. सो एक्स्ट्रा केतरा दरकार हमको इक्विलिब्रियम इक्वेशन प्लस 2टा दरकार इक्विलिब्रियम इक्वेशन. एडा हो आंसर. से क्वेश्चन टा पढ़ो. एटा लामिस थ्योरम रा एप्लीकेशन. से कहूची ए बॉक्स अछि गोटे W ठीक अच्छे तार मास दे 10 kg इज सपोर्टेड बाय टू मासलेस स्ट्रिंग एसी गोटे अच्छी ए बी गोटे अच्छी ए सी ए टू सी ए टू बी दुटा स्ट्रिंग रे ए डब्ल्यूटा सस्पेंड है द मैग्नीट्यूड ऑफ द टेंशन इन द स्ट्रिंग ए बी रे टेंशन केते पचार न्यूटन जिते थीटा 30 डिग्री ए थीटाटा जिते 30 डिग्री हम से टेंशन इन ए बी मुझे धर कहली टेंशन इन ए बी जदि पॉइंट ए रु फ्री बॉडी डायग्राम ड्र करुँची इे गोटे अच्छी टेंशन ए बी ये गोटे अच्छी टेंशन कौन टेंशन इन द स्ट्रिंग ए सी तलू अच्छी वेटा के ना मास देची 10 जी वैल्यू धर 9.8 नियरली मैंने 10 सो ये 100 न्यूटन एम जी सो बर्तमान मुझे लामिस थ्योरम ये पॉइंट अप्लाई करी केमती लामिस थ्योरम अप्लाई करी टी ए बी है यहाँ एंगल बिटवीन अदर टू 9 साइन 150 डिग्री साइन 150 डिग्री इज इक्वल टू डब्ल्यू माने 100 कौड़ा डब्ल्यूटा अदर टू भितर एंगल के एंगलटा जदि यहाँ 30 60 90 है टोटाल अधिक लेफ्ट रहा 90 यहाँ साइन 90 डिग्री साइन 90 डिग्री वैल्यू 1 साइन 150 डिग्री के साइन 180 डिग्री माइनस 30 डिग्री इज इक्वल टू साइन 150 डिग्री साइन 180 डिग्री माइनस थीटा मैंने साइन थीटा सो यहाँ साइन 30 डिग्री साइन 30 डिग्री वैल्यू है 1/2 ये जब 1/2 कर मल्टीप्लाई हेले यहाँ जो 50 सो टोटाल हम आंसर 50 टी ए बी वैल्यू सो टी ए बी वैल्यू हो 50 बुझल से व्हाट इज द मैग्नीट्यूड ऑफ टेंशन ए सी रे अगेन से थे लामिस थ्योरम पका ये समान चित्र रे टी ए सी कैलकुलेट हम टी ए सी है यहाँ टी ए सी अदर एंगल के 9 3 12 साइन 120 डिग्री इज इक्वल टू सी कौन डब्ल्यू डाउनवर्ड अच्छी 100 न्यूटन डब्ल्यू अपोजिट ये एंगलटा के 90 डिग्री सो साइन 90 डिग्री साइन 90 डिग्री वैल्यू है 1 साइन 120 डिग्री वैल्यू है के साइन 60 डिग्री साइन 180 डिग्री माइनस 60 डिग्री है साइन 120 डिग्री सो यहाँ हम √3/2 आर वैल्यूटा सो यार वैल्यू हूँ के 100 इंटू √3/2 इज इक्वल टू टी ए सी यार वैल्यू जी बाहर 50 इंटू √3 हम 50 इंटू √3 न्यूटन हम यहीटा सेमती गोटे कौन ना गिवन दैट मैक्सिमम टेंशन इन ए बी रे मैक्सिमम टेंशन के ना 75 न्यूटन से देदेला जिते थीटा 40.9 डिग्री 40.9 डिग्री नेले किसी कैलकुलेशन डिफिकल्टी हम मुझे कौन कर दूसरी यहाँ आम नहीं 30 डिग्री कैलकुलेशन सिंप्लीफाई ठीक अच्छे कम क्वेश्चन एमती डिफिकल्ट एंगल किसी दबनी सो आई एम टेकिंग द एंगल एज 30 डिग्री देन व्हाट आस्क्ड what is the maximum weight W in Newton that can be supported without breaking the string see एटा हला कंडीशन समान कंडीशन सी खाली कही दउची टी ए बी रो वैल्यू दे देजी 75 न्यूटन ता माने एटा से पचारुची W टा केते हो यदि टी ए बी एतिके हला W रो वैल्यू केते हो लामिस थ्योरम अगेन अप्लाई करो 75 डिवाइडेड बाय एटा हला 75 ए एंगल टा केते 9 साइन 150 डिग्री साइन 150 डिग्री इज इक्वल टू टी ए बी रो वैल्यू रोला यहाँ तापर डब्ल्यू लेख यहाँ डब्ल्यू रो अपोजिट रे एंगल टा के साइन 90 डिग्री डिवाइडेड बाय साइन 90 डिग्री इज इक्वल टू टी ए सी रो दे दियो टी ए सी डिवाइडेड बाय एटार के साइन 9 3 12 साइन 120 डिग्री सी खाली कौन ये दुटा को नहीं जाओ तुम इक्वेशन करी डब्ल्यू आराम मल्टीप्लिकेशन क्रॉस मल्टीप्लिकेशन करके आंसर काट दियो डब्ल्यू रो वैल्यू केते साइन 90 तो 1 है साइन 150 डिग्री माने साइन 30 डिग्री 1/2 सो यहाँ है 150 डब्ल्यू इज इक्वल टू 1/2 डिनोमिनेटर अच्छे ऊपर गले मल्टीप्लाई हो 75 × 150 सो यहाँ है डब्ल्यू 150 केते ना जिते आम थीटा नहीं जा 30 डिग्री गिवेन अच्छी 40 डिग्री अनुसार कैलकुलेशन हम सो नो वरी so in this way this type of equilibrium equation will be solved okay here is a question related to again see how we will calculate this one Here is a given beam and hinge support. At B there is a roll load support. So hinge will provide two types of reaction. Suppose it will provide a vertical reaction and a horizontal reaction. Okay, it is a roller, it will only provide a vertical reaction. Getting my point? Okay, so these are the support reaction for the situation. What the question asked in the question 7, the magnitude of the horizontal reaction in kilonewton at support B. At support B re horizontal reaction, he is asking about the horizontal reaction for the roller support. The answer simply 0. Such type of question will be asked in 1 mark. Okay, no calculation required, because roller will give only a vertical reaction. Then second question is saying the magnitude of the horizontal reaction in kilonewton. Magnitude of the horizontal reaction in kilonewton at support A. He is talking about this one, HA. Okay, this is VA, HA. He is talking about HA. HA is equal to how much? He is talking about. How will apply? Just in this, for calculation of support reaction, you need to draw the free body diagram of the beam. Okay, this again you show the reaction force, that is the vertical, again vertical A, this is the horizontal A, here is inclined force, here again is inclined force, this is 20 kilonewton, this is 30 kilonewton. Again for simplification, it's at 70 degree I am taking as 60 degree, 35 degree I am taking as 30 degree. Okay, if we resolve this into horizontal and vertical, okay, like this, you will get the sine component. This one will be 30 sine 30 degree, this one will be 30 cos 30 degree. Again we will resolve like this force, inclined force. That's why in the first video I was saying the resolution is very important. So the cos component cos 60, this one will be 20 magnitude into cos component cos 60 degree, the upper one will be sine component. Okay, like this. Then after resolving these, we can apply net force in horizontal direction is equal to 0, net force in vertical direction is equal to 0, and net moment about any point is equal to 0. These are the equation available. By using these concept, we can answer all these questions. See, we need the horizontal HA. Okay, this value we need HA. Now what I'm doing, I'm taking the horizontal, net horizontal force is equal to 0. I'm applying this equation. Okay, I'm not writing F subscript F for ease, I'm writing like this, net horizontal force is equal to 0. So HA, okay, positive, then we have plus 30 cos 60 degree, then we have in the other direction, that is 20 cos 60 degree. Okay, so from here HA can be calculated easily. Similarly, the magnitude of the vertical reaction at support A, VA, how we will calculate VA? For calculation of VA, see how many forces are there. This is the force I am showing, how many forces are there in the beam. This is a force, this is a force. After removing this force, we have resolved into these two force. So here are two force, again we have two force here. Okay, here is a single force. So total we have 1 2 3 4 5 6 7 force. So in this situation, he is asking the support reaction. Out of the 7 force, we have 3 unknown. This is a unknown, this is a unknown, this is a unknown, this is a unknown. So we need this unknown value. So I will take the moment about the other point which is passing through the line of action of the other unknown. Okay, so that I don't need to calculate moment due to this force. This force will calculate this force. Okay, this force will pass through the same point, this force will pass through the same point. So moment due to this vertical and the horizontal will be 0. So only I will get the moment of this vertical A. Okay, so for this question I will apply net moment about the point B is equal to 0. Then applying the moment equation, I can simply calculate this answer. Okay, Then in the next question it is asked the magnitude of the vertical reaction in kilonewton at support B. For support A vertical reaction I was taking the moment about B. For this value I need to take moment about this point, so that the moment due to these two forces will be cancelled out. The HA and VA will be having zero moment about this point. But the force, here is the vertical force and two force, these are the force 1, 2 and 3. These three will give moment, and these two also passing through the same point, so no moment due to these 3, 4 forces. So only 3 forces will give moment. So I am applying net moment about the point A is equal to 0. You will get the vertical at the point B. VB will be calculated. Here we can calculate VA. So all these things you can calculate very easily. I am just giving you as a homework for calculation. The concept I have given you. Okay, I am going for the next question. So this is the question. So take the screenshot of this one and try. Okay, this question we have discussed. Again, this is a 2-mark question. If time will permit, we will do this question, else we will proceed further. Okay, so see this question. The maximum number of independent equilibrium equation. He is talking about maximum number of equilibrium independent equation available at the chord section when a method of section is used for analyzing planar truss. See, I was saying in the last video the method of section. In the method of section, what I was saying, cut the section into two, so that such that maximum 3 cut. Okay, maximum 3 member should be cut, maximum. Okay, this is the maximum 3. So in that case, suppose this is a truss given like this. Okay, and here is a load applied in this direction P. Here is a hinge and here is a roller support, and it is asked for the internal force in the member like this. This is the member I need to calculate. Okay, in that case, how I will take, if I will apply the method of section, that means I will cut this like this. Okay, so there will be two sections, the down one, this will be another section, the first section, other one will be the second section. In the second point of method of section, I have told you that you should take the section which is containing less calculation. So we will take the upper part which is containing less calculation. So I'm again showing the less. So the left portion will be like this. Here is a force of P is applied. So these are the internal force after cutting in the member. Okay, so can we apply the equilibrium equation in this part, into the down part? Yes. So it is the question simply asking, can we apply the question is asking maximum number of independent equilibrium equation available at a chord section whenever the method of section is used. So in a planar case we have only 3. Okay, we can apply. So in the next question, so see, this is a good example for objective type. So both the end are fixed. So in this, here you will get an horizontal and a vertical and a moment reaction. Here again you will get a horizontal, vertical and a moment reaction. So total 6 reaction. So you are getting 6 reaction. In this you are getting, it's a hinge, it will give horizontal as well as vertical. Here you will get an horizontal only. So you have only 3 reactions. In this you have a cantilever fixed, so both horizontal, vertical and a moment. So you will get 3. Here you will get another roller, so you will get 1. 3 plus 1, here you get 4. Okay, so here is a continuous beam, number of support hinge, it will give a horizontal as well as vertical. Here is a roller, will give only vertical. Here is a roller, will give only vertical. Here is a roller, only give vertical. So here is 2 hinge, then roller, 4 roller, 2 plus 4, there is 6 reaction. Here is a simple supported beam, only hinge will give horizontal vertical and the roller will give the vertical only. So you have only 3. In this beam it's a cantilever, only 1, 2 and 3. Okay, so you have 3. So in the equilibrium equation, available for 2D is equal to 3. आम पाखे 3टा अच्छे जदि अधिक अननोन होला सेटा है स्टैटिकली इनडिटरमिनेट कौन भी जदि अननोन अधिक होला सेटा है स्टैटिकली इनडिटरमिनेट जदि अननोनटा कमीगला सेटा है डेफिशिएंट जदि अननोन सांगे समान अच्छी ताहले स्टैटिकली डिटरमिनेट ठीक अच्छे आम यहाँ पढ़ी देचे टाइप ऑफ बीम रे सो द फास्ट बीम एटा को बीम सी कहूँ ए नंबर बीम यार ना कौन एटा फिक्स्ड बीम ए ऑप्शन ए रो नाटा कौन फिक्स देखो ये फिक्स्ड लिखाई एटा को ऑप्शन एल ऑप्शन ए एल तापर एटा स्टैटिकली डिटरमिनेट ना इनडिटरमिनेट एटा हम स्टैटिकली इनडिटरमिनेट ता माने एन हला कोड हला एन सेकंड ऑप्शन हला बी बी रे को बीम देजी बी रे देजी गोटे को बीम एटा हला गोटे 3टा ओवरहैंग बीम माने सिंपल सपोर्टेड रो एक्स्ट्रा पार्ट बाहर को ता कहंदी ओवरहैंग बीम एटा हला ओवरहैंग बीम एडी ओवरहैंग बीम सो बी नंबर होची एटा कोन आई देची आर नंबरिंग टा आई एटार केतेटा रिएक्शन अछि 3टा अछि ता माने स्टैटिकली डिटरमिनेट आम लिखिया एम स्टैटिकली डिटरमिनेट बाय ठीक अछि 3 नंबर सी देखिया सी रे को बीम एटा हला सी गोटे कैंटिलीवर ता संगे गोटे एक्स्ट्रा सपोर्ट अछि कैंटिलीवर ता कहंदी प्रॉप्ड कैंटिलीवर कोन कहंदी प्रॉप्ड कैंटिलीवर ओके सो सी रो हला के एडी केतेटा रिएक्शन अछि 4टा अछि 4टा को आम कौन कह स्टैटिकली इनडिटरमिनेट कमी 3टा रो अधिक हेले स्टैटिकली इनडिटरमिनेट एन ओके एटा कौन डी डी रे कौन देछि एटा को बीम ना गोटे देछि कंटीन्यूअस बीम बहुत सारा अछि सो कंटीन्यूअस बीम रे कौन आम लिखिबा कंटीन्यूअस बीम एटा हला कंटीन्यूअस बीम जे कंटीन्यूअस बीम रे केतेटा रिएक्शन 6टा इज इट पॉसिबल टू सॉल्व स्टैटिकली डिटरमिनेट इक्वेशन नो इट्स एन स्टैटिकली इनडिटरमिनेट जोठी 3टा रो अधिक अछि रिएक्शन सेटा स्टैटिकली इनडिटरमिनेट नो एट देखो 3टा अछि एटा कोन सिंपल सपोर्टेड बीम खाली गोटे एपटे हिंज थिला एपटे गोटे रोलर टे थिला सो एटा हला सिंपल सपोर्टेड बीम एटा कोन ना एच सो ई टा हला एच एटा स्टैटिकल डिटरमिनेंट यस 3टा अछि माने स्टैटिकल डिटरमिनेंट एम एफ नंबर रे कोन अछि को बीम एटा एटा हला गोटे कैंटिलीवर हला एडी ऑप्शन जी एटा भी 3टा रिएक्शन अछि माने स्टैटिकल डिटरमिनेंट एटा हला ऑप्शन ठीक अछि एटा गोटे लॉन्ग क्वेश्चन माने 2-3 मार्क रो क्वेश्चन एथुर गोटे सिंगल को भी पार्ट रो भी क्वेश्चन पचरि पारे ठीक अछि सो एटा हो आंसर मु जस्ट लिखे दोची क्लियर विजिबल हो सब जगह सो दिस इज ए वेरी गुड क्वेश्चन फॉर एमसीक्यू टाइप क्वेश्चन ओके again you see this question 18 19 20 okay for this given structure okay this truss what the question what is the magnitude of the net reaction he's talking about net reaction at the support C this is the support C before that C can you see these are the two member not collinear to each other they are so the joint D is not because for a joint to be in equilibrium whenever whether it is a particle or a object a joint if there is two forces are acting for the equilibrium of that particle or object or joint the two forces must be equal in magnitude opposite in direction and collinear to each other here they are not collinear so it's a zero force member okay since again these two will be zero force member okay so if I'm removing all these force again I'm drawing the truss diagram so after removing this is the truss diagram here is a 50 kilonewton here is a so this is 50 kilonewton this is the point A this is the point called B this is C this is E okay this height is given 10 this is also given 10 and this is also given 10 and since it is a roller support so only vertical force will be here so it's a vertical at point A here is a hinge so there will be two reaction that is vertical at point C and horizontal at point C. If I'm taking any wrong direction in assumption, the answer will be negative and I will just alter the direction of this support reaction. Don't worry how I'm taking this reaction direction. I'm just taking randomly. Okay. If the answer will be negative, then I will change the upward will be downward, the left will be right, the up will be down. Okay. If there is a negative in the answer. So now he's saying the net reaction at support C. So at the support C, I need to calculate HC and VC. Then I will calculate the resultant of HC and VC by using the parallelogram law. Okay. The root over of P square plus Q square plus 2PQ cos theta. Okay, that one. Otherwise, here is a 90-degree condition. So here the resultant will be like this: horizontal square plus vertical square. Okay, so horizontal, what is horizontal, vertical, let's calculate first. For the horizontal, I'm writing the equation net horizontal force is equal to 0. So this is the 50 kilonewton negative axis, so minus 50. Then here is also negative, minus H at C is equal to 0. In that case, I'm getting HC is equal to minus 50. So kilonewton, I'm getting negative answer. So HC direction assumed is wrong. So the actual direction of H, the actual direction is in this direction. So it is not like this. So the actual direction in the other direction. Okay. Now I'm just leaving is like this. HC is 50 kilonewton. Okay. In the direction rightward. Okay. Again, I need to calculate what? The vertical. So for vertical, I'm applying the equation net vertical force is equal to 0. Here is a vertical reaction, that is VA upward positive, then again VC upward positive is equal to downward 50. So this is a equation I got. Now for the calculation of VC, what I can do, taking moment about the point A, so that the moment due to this unknown will be 0. This is an unknown force, this is also an unknown force. If I am taking the moment about this point, the line of action of VA is passing through this point and the line of action of HC also passing through the same point. So the moment due to these unknown, two unknown will be 0. So I can easily calculate VC. So I am taking moment about point A is equal to 0. So in that case, what are the force which will give moment? Here is the force, here is the force, and here is the force. 3 force will give. So I am taking first clock 50 kilonewton. 50 kilonewton into perpendicular distance is 10. Okay, perpendicular distance is 10. 50 into 10, it is clockwise or counterclockwise? Counterclockwise positive. Okay, then I will take this force. This is also 50 kilonewton. 50 kilonewton into perpendicular distance is 10. Okay, it's clockwise. Okay, in this sense, this is rotating in this sense. Getting my point? So this force is counterclockwise, this is clockwise. So in this situation, it will be clockwise negative. Again, I have another VC upward. So VC into perpendicular distance is 20 is equal to 0. What will be the direction of this movement? It's counterclockwise, so positive. So from here I can calculate this value will be cancelled out. So VC will be equal to 0. Okay, this is the VC. So you got horizontal is equal to 50 kilonewton, vertical is equal to, so in that case, if you put H is equal to 50, V is equal to 0, you got resultant is equal to 50 kilonewton as answer. Okay. In the second question, what is the magnitude of the net reaction at the support A? At the support A, the net reaction is the vertical reaction because there is no horizontal reaction. So you need to calculate VA. How you will calculate VA? By applying net moment about this point is equal to 0. So the moment due to these unknown, two unknown will be 0. So you need to just write the equation net moment about the point C is equal to 0. You will get VA very easily. Again, what is the force in the member ED? In the ED, in this member, what is the force? It's 0. So answer will be 0. Okay. Likewise, you will be able to solve this type of question. So now read this question carefully. An attempt is made to pull the roller of weight W over a curve by applying a horizontal force F as shown in the figure. Here is the figure given. The coefficient of static friction between the roller and the ground. The roller and the ground. Here is the coefficient of friction is mu, including the edge of the step. Here also the coefficient of friction is mu. Identify the correct free body diagram for this condition when the roller is just about to climb. Is just about to climb mean at the verge of motion. At the verge of motion, the object is not in dynamic condition, so it is in equilibrium condition. After that, the body will try to rotate about this. So for drawing the free body diagram, isolate that roller, okay, show the weight W, okay, the external load F, yes. See, the roller is just about rotating about this point, so it is not in motion, so it is in equilibrium, so there is a contact force at this point. And here is the roller, there is 3 forces, so for equilibrium these 3 forces must concurrent to each other, so the force will be passed through this center, okay. So this will be the condition of free body diagram. Friction will come into picture whenever the body is trying to be in motion, okay. Here is a point contact, no motion, okay. About this point it's trying to just climb up, so this is the perfect free body diagram. Again, in the next question, he is talking about the force produced in the CD. See, CD in this member is talking about the force. Here as you can see, these two are collinear. The force in this member is equal to 0. Again, these two are collinear, so the force in member CD will be 0. So the answer will be 0. By applying the concept like this, whenever two are collinear, the third one will be 0. Whenever these two are 0, I am just applying this concept, I am getting the answer as 0. Okay. This is also whenever two member, there is no external joint, no external load at the joint. In that case, these are the two special case of truss. So mostly the 1 mark question will come from this concept only. Okay, 2 force member and 0 force member. Okay. In this question, he is talking about S1 and S2 calculation. The weight of the bar is 100 Newton. See, this is the bar. Here is a 100 Newton is acting. Here is again and T2. Here is a T1. See, in these 3 forces are acting. So out of these 3, the 2 are collinear to each other. So for balancing these 2, if you apply the horizontal force in the component is equal to 0, you will get T1 plus T2 is equal to 100 Newton. If you take moment about this one, you will get the 0 moment, because this is the same distance for the both the force. So T2 into x, suppose this is x, is equal to downward, this is the counterclockwise, this is the clockwise, is equal to 100 into x, x calculated. So T2 is equal to 100 Newton. Tensile, because it is in upward direction, okay. From this point it is a tension always towards the other end. Here T1 will be how much? T2, since it is 100, so T1 will be 0. So T1 is equal to 0, T2 is equal to 100. This is the question answer. By applying just equilibrium equation, you can answer this type of question. Again, the free body diagram of this diagram, here is a fixed support. So fixed support means if I'll draw that object like this, again like this, here is a external force F. Here, since it is a fixed support, I will remove. Here will be a vertical one, a horizontal one, and a moment. Okay, moment, horizontal, vertical, and it's the external force. So this is the free body diagram. Where is this? Here is the diagram, free body diagram. Here the support is not removed. Okay, so this cannot be the answer. Here is horizontal, vertical, moment, and external force. Okay, and this question we have already discussed in the last video. So thank you for watching. We have successfully completed the chapter equilibrium and truss, and we have done a lot of numerical based on these concepts. So in the next video we will discuss about the friction and some numerical related to that. Okay, thank you.